Good morning, majors. Today we're starting Unit 4, Day 1, classifying triangles and triangle sum theorem. In this section of the note, we're going to be going over the objective. I can apply the angle sum theorem and exterior angle theorem to solve for a missing angle. Before we get to going in depth on triangle sum and the exterior angle theorem, we wanted to just remind you some of the things about triangles. I'm sure you guys have seen it before, but I just want to make sure we are on the same page when we're talking about. So triangles can be classified using their sides and then using their angles. Okay. So what are the classification of triangles using their side? One is scaling triangle. The other one is isosceles triangle and equilateral triangle. I think most of you are familiar with equilateral triangle, but we just want to make sure everybody's on the same page. So if a triangle as a scaling, the definition is no side have the same measure. That means each of the sides are going to be different. This can be 6, this can be 7, this can be 8. So when you have a triangle where none of the sides nor the angles are congruent, we call that triangle a scalene triangle. The next one, when we use a side, is an isosceles triangle. If I have two triangles, two sides of this triangle to be the same, so let's say if this is 7, this would be 7, or if this is 8, this would be 8, this is 9, this would be 9. I'm just randomly picking numbers. But if I have a triangle where two of the sides are equal, then it's called an isosceles triangle. And equilateral triangle, as you guys probably can guess from the word itself, equilateral, that means all sides are going to be congruent. So if it's 10, 10, 10, 20, 20, 20, 5, 5, 5, whatever it is, always the triangles are going to be equal to each other. All right, so the next one is trying to classify triangles using their angles. Now we look at this one would be 4 types of angles. One is acute, obtuse, right, which we went over this before, and this is equiangular. So acute angle triangles are all 3 angles are acute, not 2, not 1, but all of them are going to be less than 90 degrees. Okay. When it is obtuse, obese, it comes from that, where has 1 obtuse angle and 2 acute angles. Because if I have, let's say, 95, the other angles cannot be more than 95, right? Because then it's going to pass the 180 degrees. So if I have 120 degree and then the other, so and also when we're looking at this type of triangles, you also can see, okay, this is an obtuse triangle, and looking at the side, these two are the same. This can be obtuse isosceles triangle. Okay, obtuse isosceles triangle. So it's possible to name a triangle using their angle and using their side. A right triangle is a triangle that has one 90 degree and the other 2 angles are going to be acute. So if this is 90, the other 2 angles are going to be acute. And when we did our distance in Unit 1, we talked about right triangles, a squared, b squared, c squared, if you guys remember. One thing I wanted to add into this is also, if I have a right triangle, the other 2 angles, in this case A and B, also going to add up to 90. They're going to add up to 90 degree angles, because if these 2 are 90, this is 90, 90 plus 90 gives you 180. And I know we go over this a little bit more on the next page. When it's equiangular, that means all 3 angles are going to be congruent, which if you take 180 degree divided by 3, each of them is going to be 60, 60, 60 degree. So the angles are always 60 degree angles. The side can be 5, 5, 5, 10, 10, 10, 20, 20. Doesn't matter, but the angles are always stays the same. All right, so make sure you guys remember this. This is maybe from your 8th grade math or 7th grade math. But everybody should know this, classifying triangles by its angles and by its sides. All right, so this is the main part we're talking about today, triangle sum theorem. And I'm sure you have, but any triangle can be acute, obtuse, right? The sum of the measure of an angle of a triangle is always 180 degrees. Always. It can be big, it can be small, but it is always going to be 180 degrees. Okay? So most of the time, you have problems like this. It asks you find each angle measure. So they gave you B is 100, A is 30. What would be the measure of C? So we know if I add 100 plus 30 plus whatever angle C is, I need to get 180 degrees because it's a triangle, right? So if you add 101 plus 30, it gives you 130 equals 180. Then you do minus 130 from both sides, and you can see that C would be 50 degrees, right? So that's what be the measure of C. Okay, that's what you guys have to do. So I'm gonna let you guys do number 2 and the second part, and I'll do this piece. Okay, so one thing you have to understand is when you started geometry, everything would be probably one step, right? A triangle sum is always 180, but we are in unit 4 now. So what we learned in unit 1, unit 2, unit 3, sometimes we'll come back to this unit to help us find the missing angle. So in this case, to find x, I can look at this triangle and easily find this x, right? So I can say, okay, x is going to be 43 plus 59 plus x equals 180. Alright, so when you add 43 plus 59, you'll get 102, right? This would give you 102 plus x equals to 180. So when you subtract 102 from both sides, you would get 78. Okay, so that's going to be the measure of angle x. So I'm going to erase this so that we can kind of see what we did. Okay, so now I got the measure of angle x equals to 78. So I got this to be 78. Okay, so now I'm trying to find the next variable in this case, which is y. So what do you think I should be using to find y? This is going back to unit 1. Remember we talked about linear pairs? So if I know this is 78, this would be y. Okay, I hope you guys got it. A straight line add up to 180. So to solve for y, I can do 180 minus 78. Okay, so 180 minus 78 will give you 102. So y would be 102. And then now I can find the z, right? I have 102 here. I have 49 here. What would be z? So this is your question. Okay, so find out what it is. All right, so the next one is one thing I need you guys to remember. We talked about what acute angle is, and I mentioned it earlier. The acute angle of a right triangle, or the sum of the two acute angles of the right triangles, are going to add up to 90 degrees. So the sum would be 90 degrees. Okay, the measure of each angle in equilateral is going to be 60 degrees, and I went over it on the first page, but just to make sure we have it written down. So the last theorem we're going to go over for this part would be exterior angle theorem. The measure of the exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles. So how do we get an exterior angle? If you have a triangle and if you extend one side, so for example, if I have this, if I extend this, this becomes the exterior angle. If I extend this up, this becomes an exterior angle. The same thing In this case, this would be my exterior angle. Okay, it says the measure of the exterior angle, the measure of this angle of the triangle is equal to the sum of the two remote interior angles. So if this is the two remote interior angles are the non-adjacent angles, that means the remote interior angle for C would be the sum of A plus B. Okay, angle A plus angle B. Okay, so what angle A plus angle B is going to add up to the measure of angle, I don't want, so I have to kind of let me label this B. It's going to be angle B, C, D. So that's what this is going to equal to. So in this case, to solve for X, I can do, okay, X plus 65, that's B, right, equals to 2X plus 16. Okay, that's what this is, right? Let's see. No, equals to 10. Sorry, see so equals to 10. The sum of the remote interior angle equals to the remote interior angle, which is this, equals to the sum of the two. The exterior angle equals to the sum of the two remote interior angles. So what we need to do is we can do minus x from both sides, and then I can do minus 10 to this side, so that I have the variable one side and the x on the other side. Sorry guys. So 65 minus 10 is 55, and 2x minus x is x. So the measure of angle x, or the measure of x, is going to be 55. Okay, and then you can plug it in. All right, so the next one is just the converse of it. Okay, the base angle theorem of all right, so in this case it says if two sides, so let me use a different color. So if two sides of a triangle are congruent, then the angle opposite them are going to be congruent. So this is more of an isosceles triangle. So what this means is, if I have a triangle, right, and if this side and this side are equal, then the side opposite to this, right, this angle and this angle are going to be congruent. So base angle theorem, we're going to get to it when we also talk about an isosceles triangle, and I think in our day 7 notes, but this is something you need to know because it applies when we try to find the measure of missing angle. The converse of a base angle theorem, it works the same way. So if, remember, converse is flipping it. So if the two angles, so this is my angles, the two angles if two angles of a triangle are congruent, then the two sides are going to be, opposite sides are going to be congruent. Okay, so I'll show you what this means, and we have 3 examples here to represent it. So this is what it means. Even if they label it as x and y, in this case, knowing that this angle here, this side, is congruent to this, and you know this is 46, this also going to be 46. That's what this means. So x is going to be 46 because it's an isosceles triangle, so the two base angles are going to be the same. To find y, I can do the triangle sum, right? 46 plus 46 plus y equals to 180. And then you guys can get to y. Here, the same thing. Even if they label this x and they label this y, it's the same number because the two sides are going to be the same, right? So two numbers that are the same, labeled differently, is going to give you, plus 40 is going to give you 180, right? So I'm going to do 180 minus 40. That'll give me 140. Then I divide it by 2. So this would be 70. This would be 70. And then for number 3, you can see that all of the angles are equal, right? This is going to be 60, 60, 60, which makes the equilateral triangle or equiangular triangle, which you can easily say, oh, the sides, all the sides are also going to be congruent. So you can say 12 equals to 2x. So you divide both sides by 2, and x would be 6. Okay? And the last thing is the third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angle are also going to be congruent. Okay, so this is a good example. So this angle marked like this is going to be the same as this angle here, so this is going to be 65. The two slashes, the same with this one, which is 55. Okay, even if you don't know what this is also the same as the other one, because the 65, 65, 55, 55, that are the two angles. So it's two angles of one triangle are congruent, right? Two angles of one triangle congruent and to the two angles of another triangle, which we can see here. Then the third angle is going to be the same. So this is also going to be 2x plus 30. Okay? And then, of course, to solve for x, I will add it up, make it equal to 180. So you'll do 55 plus 65 plus 2x plus 30 equals 180. So add up the numbers. So you're going to add 55 plus 65 plus 30 gives you 150 plus 2x equals 180, right? So you'll do minus 150 minus 150, 2x equals to what? 30. Then of course you divide both sides by 2, and x will be 15. Alright, so that's it, folks. And we'll start Unit 4 day 2 next time. Have a good day.